Okay, example 5. But before I go into example 5, I need to explain to you again about example 4. So why did I use destructive interference when your equation is because constructive interference would cause a much more brighter I mean, it would cause the light to come in into the camera lens more, right? So it can reflect this yellow green light more. So to limit these reflections, the lens are coated with this magnesium fluoride lah. So this coating of magnesium fluoride limits this reflection and causes what we call destructive interference lah. Okay, so I'm gonna write here destructive interference lah. That's why we use to limit the reflection, to limit reflections, to limit reflections. That's why the magnesium fluoride is used, and this layer of magnesium fluoride causes a destructive interference. Okay, all right, then example 5. Now for example 5, white light is incident on a soap film of refractive index 1.3 in air. The reflected light looks bluish because the red light of wavelength 670 nanometer is absent in the reflection. So this one is for white light incident on a soap film that is for less dense medium, remember? So we have air, we have the soap film, and then balikan. So this is N1, and then N2 1.3, and 1 is back as A lah. This is for soap film kan. So we have to state the condition for destructive interference. So the condition for destructive interference is basically just write it as 2nt equal to m lambda lah. And then what is the minimum thickness of the soap film? So minimum thickness m should be equal to 1. So that is m lambda. So you will get the minimum thickness to be equal to 258 nanometer. Okay? Alright, yeah, that is on example number 5.